Okay, so we're on page 44 and we're working on questions 1 through 15 and possibly 16. Question number 1 is asking for the measure of arc BC. We can see here that we have angle BAC, which is an inscribed angle in circle O, and we know that the relationship between an arc and an inscribed angle is that the inscribed angle is half the size of the arc that it touches, or that the arc is twice as big as the inscribed angle. So if my inscribed angle here is 37, well, then I know that the arc that it creates is going to be 74 degrees. If we look at question number two, they tell us that the inscribed angle has a measure of 48 degrees. So naturally, if the inscribed angle is 48, the arc that it creates is going to be twice as big. 48 times 2 is 96. But the question is asking us to find the measure of arc BC, which is the arc up here. Well, the first thing you should notice is that these two chords are congruent. And if you remember the rule, it says that if two chords are congruent, then the arcs that they create are also going to be congruent. So a circle has 360 degrees. And from 360, I'm going to subtract 96. And whatever's left over, I'm going to divide it between these two arcs. And that's going to give me 132 degrees apiece. So the measure of arc BC is 132 degrees. Number 3, they tell me that the central angle here is 87 degrees, which means that this arc that it creates is also going to be 87 degrees because it is a central angle. And then they want to know what is the measure of inscribed angle BAC. Well, the inscribed angle is touching that arc, which is 87 degrees, and it's going to be half of that arc. So 87 degrees divided by 2 gives me 43.5. Question number 4 is exactly like the question we saw on page 43, where they're asking us, where they're giving us an inscribed angle with a measure of 28 degrees, and they're asking us for the arc. Of course, you know that the relationship between an inscribed angle and the arc that it creates is that it is half the size of the arc, where the arc is twice the size of the inscribed angle. So 28 times 2 is 56. Number 5 was a little bit tricky, just a little bit tricky. But if you look here at number 5, if you notice, segment BD is a diameter. And a diameter creates a semicircle, which is 180 degrees. They tell you here that this central angle is 142 degrees. So if this central angle is 142 degrees, the arc that it creates is also going to be 142 degrees. However, though, I know that BD is a diameter. So then if I subtract 142 from 180, I know that arc BC is going to be 38 degrees. Because 142 plus 38 gives me 180, and that's a semicircle. Well, now that I can see here that this arc is 38 degrees, I can also see that I have an inscribed angle BAC. And of course, we know inscribed angles are half the size of their arcs, so 38 divided by 2, and we get 19. So the measure of angle BAC is 19. Question number 6 is very similar. In question number 6, you have a, if you notice here, give me one moment. Okay, I hope that you notice that AC is a diameter, and a diameter bisects a circle into two semicircles. So this semicircle here should be 180 degrees. This arrow here is pointing out to you that this central angle here is 138 degrees, which means then that this arc here is also going to be 138 degrees. But of course we know that a diameter itself creates a semicircle. So if this is 138 degrees, well, we can find the remainder by subtracting 138 from 180. And that's going to give us 42 degrees. So I know that arc BC is 42 degrees. And now if you look, you have an inscribed angle again, angle BAC. And of course you know the inscribed angle is half of the arc that it creates. So half of 42 is 21. So the measure of angle BAC is 41 degrees. Let's take a look at questions 7 through 14. Okay, for questions 7 through 14, they give us two givens. The first given that they give us is they tell us that arc CD is 86 degrees, and they tell me that arc BE is 95 degrees. So let's start with that first. If you look at arc CD, which is 86 degrees, I hope you can see here that it's inscribed with angle CBD or DBC. And if this is 86 degrees, well then I know that this angle here is going to be 43 degrees, half of that. So right away, we can answer question number 10, which is what is the measure of angle CBD? And that's going to be equal to 43 degrees. So number 10 is 43 degrees. Do we have any other inscribed angles with arc CD? And the answer is yes. If here I highlighted it in yellow, you can see here that angle CED or DEC is also inscribed with arc DE. So angle DEC or angle CED is also going to be half of 86, which is also going to give us 43 degrees. And with that, we can also answer question number 8. So the measure of angle CED is also equal to 43 degrees. Now that we've put all this attention into the first arc that they gave us, let's focus a little bit more on this second arc here, at arc BE. And we know that it's 95 degrees. I think it's pretty obvious what the inscribed angle is for that, right? I hope we can see that it's angle BCE, right? Hope you can see how these two endpoints come together to this angle here. So we have angle BCE is half of 95. So let me see here, 90, half of 90 is 45, half of 2 is 2.5. So this angle here is going to be 47.5 degrees. So angle BCE is 47.5. So with that, we can answer question number 12. Measure of angle BCE is equal to 47.5 degrees. Are there any other inscribed angles with arc BE? Well, yes, there is. If you look here, you have angle BDE or EDB. Again, this is also these two rays of the angle here are inscribed with are intercepting arc BE, so it's also going to be half of that right there. So this is also going to be 47.5 degrees, angle BDE. So angle BDE, that's question number 8, is also going to be 47.5 degrees, half of 95. Is there any other information that we can see here? Well, let's take a look at question number 7. Let's start at question number 7. Question number 7 is asking, what is the measure of angle ABC? Well, here I have ABC. And I hope you can see here that the endpoints of angle ABC are in fact a diameter of the circle. And a diameter creates a semicircle, which means then a semicircle has 180 degrees. So if this is a if this semicircle has 180 degrees, then its inscribed angle is going to be half of that. And half of 180 degrees is 90 degrees. So angle ABC is going to be 90 degrees because it is the arc that it is creating is a semicircle with this diameter here. So angle ABC is going to be 90 degrees. But now that we know that angle ABC is 90 degrees, well then I should be able to figure out what this angle here is. Because if angle ABC is 90 and this is 43, well then I should be able to figure out this angle here. So 90 minus 43 is going to give me 47. Because 43 and 47 is 90. So now I know that the measure of angle ABD, A or DBA or ABD is 47 degrees. And with that, I can answer question number 11. Question number 11 is equal to 47 degrees. But now that I know that angle ABD is 47 degrees, well, now I can answer another question. What arc is it creating? What arc is angle ABD creating? Well, I hope you can notice here that it's creating arc AD. And if this inscribed angle is 47 degrees, well then the arc that it creates is going to be twice as big. It's going to be twice as big. So this is 47 degrees, then its arc is going to be 47 times 2, which is 94 degrees. So the measure of arc AD is going to be 94 degrees, which is question number 13. That's going to be equal to 94 degrees. And finally, we're left to the last question, which is question question number 14, and is asking for what is the measure of arc ABC. And if you notice, the endpoints of arc ABC are the endpoints of a diameter. So again, we have a diameter creating a semicircle, and we know that a semicircle has 180 degrees in it. So the measure of arc ABC is going to be 180 degrees, which is the answer to question number 14. Let's move on to question number 15. Question number 15, they're asking us for the value of x. If we look here, they tell us that this arc here is 208 degrees. I have an inscribed angle here. Well, I know that if this is 208, I know this angle here is going to be half of 208, which is equal to 104 degrees. But it's also 5x plus 4. So then if this is 104 degrees, I can say that 5x plus 4 is equal to 104. Subtract 4 from both sides. 5x comes down. The 4's cancel out. 104 minus 4 is 100. Divide both sides by 5. And x is equal to 20. And we found the value of x. If you're looking at question number 16, notice here that I have this inscribed angle touching this arc, and I have another inscribed angle touching the exact same arc. I don't know how big the arc is, but I do know that these two inscribed angles are touching the same arc, so they are going to be congruent. So then I can set up my equation to say that 2x plus 11 is equal to 4x minus 3, because these two inscribed angles are touching the same arc, so they're going to be congruent. And then from there, you should know how to do that problem, how to solve for x. I'm not going to waste time doing that. So we can say that 2x plus 11 is equal to 4x minus 3, because these two inscribed angles are corresponding to the same arc.